Okay, so hello all. In this class we'll discuss inversion of four-bar chain. So last session we have discussed there are four possibilities where we can fix the links and we can achieve the motion between the different configurations. So these are the four configurations. Link one is fixed. So in first case, link one is fixed. Motion will get transferred from rotary to rotary. In case two, crank will get fixed. We will get oscillating motion from input link, and again for output link you are getting oscillating motion. For third combinations, we have fixed the coupler intermediately and we are targeting rotary to rotary motion. And last case, we are fixed the output link and we are getting interconnected movement between link L and link Q. Now, these are the four inversions. So look at the first part. The first inversion of that four-bar chain is beam engine. So this beam engine is a consist of different linkages. Link one is the frame link, link two is the crank, link three is the connector, which is connected to lever, and link four is the piston and cylinder. That piston is sliding inside the cylinder. That will be your link number four. So in four-bar chain mechanism, rotary motion will get transferred to linear movement, and it has four links. Number of links are four. Number of pairs associated with these are three turning pair, one sliding pair. Okay. So number of pairs are four, number of links are four. So degree of freedom is one. So with the help of this beam engine, we are targeting rotary motion, or we are achieving rotary motion into linear motion. Rotary motion will get converted into linear motion. That is the basic working principle of that beam engine, which is also known as crank and lever mechanism. So this is the arrangement of that beam engine, how that motion will get transferred from rotary direction to linear direction. Okay. Then next part we have coupling rod of locomotives. This is also known as a double crank mechanism. So in case of coupling rod of locomotive, that means in case of railway wheels, we are transferring the motion from first wheel to last wheel, that is from first wheel to last wheel. So in this arrangement, what we have, the dimensions of the link 1 and link 3 are same. Similarly, the dimensions of crank are same, that is link 2 and link 4. So rotary motion will get transferred into rotary motion with the help of these equal linkages. Okay. So how this system will work, this is the way on which that system is functioning. Okay, how that system is connected to each other and how that system is working. So whenever we are accelerating the speed of input wheel, in similar fashion, we can accelerate the speed of second wheel, which is connected to third to fourth to fifth. And likewise, we can accelerate the speed of all the vehicles. Similarly, whenever we are reducing the speed, or whenever we are applying brake on that particular wheel, the brake, pneumatic brake will get applied, and we can lock the movement between these two connectors. Okay, that is from input wheel to output wheel. We can constrain the movement, we can reduce the speed of that particular bogies. Okay, so link AD and link BC are nothing but the crank of that particular system, and link AB and BC are nothing but a coupling rod. AB is fixed link, this BC link is acting as a coupling rod. And now these dimensions will remain same throughout all the bogies. Okay, the dimensions of all the pairs of these railway wheels will remain same. Okay, and that's why this system is known as a double crank mechanism. Parallel, we can increase the speed from first wheel to last wheel. Similarly, we can reduce the speed from first wheel to last wheel. That is the advantage. The next part, look at the braking system and the movement transmission. This is the rod at which we are connecting the vehicles. We have connected the wheels to the system, and how that system can apply the brakes. This is the process how that if we are applying the brake, pneumatic brake, we can control the movement of that particular wheel. Okay. Next important part is we have third mechanism, Watt's indicator. So this is the third inversion, which is also known as a double lever mechanism. So basically, this Watt's indicator mechanism is also known as Watt's straight line mechanism or double lever mechanism. So again, in case of Watt's indicator, it has four linkages. Link AC, link one, first link is the fixed link. Link two is the AC link is the lever. Again, this will be the input lever. This link CD is the output lever. And this is the intermediate link 4, which is connected to indicator plunger, or you can say piston. Okay. Now, how much path it is tracing, either in vertical direction or co-direction, that path value or displacement of that particular system can be indicated on that indicator plunger. Okay. So as we turn this part, as we turn this ABC from first position to final position, new path traveled by that system will be A dash B dash C dash. Similarly, new path traveled by that system will be F dash E to E dash. So this is the vertical movement. Now it has some limit. Up to certain angle of rotation, it can trace the linear path. That we need to identify. At how much value it can trace in that linear path, that path we need to take into account while calculating the movement of that particular mechanism. Okay. So this is the dotted line E dash. This is the path traveled by the system. Whenever we are turning that particular linkages from AC to AC dash, from AD to AD dash, from AD to A dash. Okay. This is the actual system, how it is moving. This is the path traced by the system. This is the plunger movement and how the levers L1 and L3 are connected to each other. L2 is for intermediate lever. And now this is the path traced by the system. Okay, so just if you look at the flow, this is the gas indicator which is connected to this vehicle below pixels. That real axle position, this is the moment of that plunger. So now we are balancing that any system, we identify the moment of that particular chassis frame and how can connect this chassis frame to that relative, how we can correlate that moment of that frame that we can trace with the gas indicator. So for certain angle of twist, angle of turn, we can trace this linear movement of that system. Okay. This is again one more path of that linear movement of that system can be traced. Then next we have slider mechanism. So already we have discussed that in the slider mechanism, rotary motion will get converted into linear motion. So in this slider mechanism, we have four linkages, link one fix. Link 2 is crank, link 3 connecting rod, link 4 is the piston, which is sliding inside the cylinder. Okay. So we have three turning gear, one sliding gear. Degree of freedom for the system is 1. This is the basic working principle of slider mechanism. Okay. So in case of slider mechanism, these are the inversions. First is a pendulum pump, second is oscillating cylinder engine, then third rotary internal combustion engine, then crank and throttle lever mechanism, Whitworth quick rhythm mechanism. Okay, so in case of pendulum pump or simple reciprocating engine, we have this arrangement. So crank 2 rotates, connecting rod will get moved, rotary motion get transferred with the help of connecting rod to linear motion at piston end. Piston will go to reciprocate inside that particular cylinder. Okay. Similarly, we have duplex pump that is used to supply feed water to boiler and have two pistons, which is shown in that particular slot. Okay. So we are just driving this part and we can move that piston, and as per the movement of that particular piston, we can supply that water to the boiler. Then next we have oscillating cylinder engine. Okay. Now in case of oscillating cylinder engine, we are converting reciprocating motion into rotary motion. Now that reciprocating motion will get converted into rotary motion. Basically, this mechanism is used in air pump. Okay, so we have foot pump is available. In foot pump, we are just pressing that particular pedal. So pedal will get pressed, and by pressing that particular pedal, that cylinder will slide into that piston will slide into that cylinder, and it can generate the air. We just compress that particular air, and air is coming at outlet. You can use that air to fill that particular vehicle wheel or tire. Okay, you can fill the air into the tire with the help of this mechanism. So if you look at the arrangement, how many linkages we have? We have 4 linkages. One is fixed spring, second is the crank, that is we can say lever. We are just composing that lever. The third is your piston rod, and fourth is the cylinder. Cylinder will get oscillating about this fixing. Okay, at the same time, that crank is moving, that piston is moving inside that cylinder, and it is generating pressurized air. So how many links we have? Number of links, 4 links. We have 3 turning pair is used, 1 sliding pair is used in this arrangement. So degree of freedom for such system is again 1. Similar degree of freedom is required to operate this mechanism. So this is how that oscillating cylinder is working. We are taking this as a lever, which is used to generate the pneumatic gear. Then we have next part, rotary or rotary internal combustion engine. So in case of rotary internal combustion engine, single crank is used to drive multiple pistons with the different connecting rods. Okay. So it has 6 cylinders that is rotating in a six, or you can say we can use 7 cylinders to operate that particular system. Either 6 or 7 can be used. Okay. Now single crank is used to just operate that system. Now some cylinders may move in forward direction, some cylinders may can move in outward direction, and depending upon movement of that cylinder, we can operate that particular engine. Okay, we can generate the power, we can generate the torque, and we can run that system with the help of this arrangement. Okay, so this is the arrangement of that rotor engine. So this is the movement. Some pistons are moving inside that particular slab. Of course, inward direction. Some are moving in forward direction, and based on this direction, you can generate the power or torque. Okay. So here we will stop today's class. In next class, we'll discuss crank and throttle lever mechanism.